Bamidele. In today's class, we'll be looking at a topic called hydrocarbon. Under the topic, we'll focus our attention on the meaning of hydrocarbon, classification, the basic naming of hydrocarbon, homologous series, then alkane, alkyl, alkenes, and what? Alkynes. So, let's start from the meaning of hydrocarbon. Hydrocarbon is a compound that contains two elements, which are carbon and hydrogen only. They are classified into two groups. We have the aliphatic hydrocarbons and we have the aromatic hydrocarbons. The aliphatic hydrocarbons are hydrocarbons with straight branch or ring chain. Straight branch or ring chain. The aliphatic is subdivided again into acyclic hydrocarbon and cyclic hydrocarbon. The acyclic hydrocarbon are aliphatic hydrocarbon with straight or branch chain. Example includes the alkanes, the alkene, and the alkyne. The cyclic aliphatic hydrocarbon, they are hydrocarbon with ring chain. Examples: cycloalkane, cycloalkene, e.t.c. Then the aromatic hydrocarbon. So let's take a look at the basic naming of all hydrocarbon. The other time I said hydrocarbon are compound that has two elements, carbon and what? Hydrogen. The basic naming of all hydrocarbon depends on the number of carbon atoms found in each and every hydrocarbon. The number is represented as N. And for instance, if N is equal to 1, that means you have one carbon atom in that hydrocarbon. If N is 2, we have 2 carbon atoms. If N is 3, we have 3 carbon atoms, and so on and so forth. 4 carbon atoms, 5 carbon atoms, 6. When N is 7, 7 carbon atoms. When N is 8, 8 carbon atoms. When N is 9, 9 carbon atoms. And when N is 10, we have 10 carbon atoms. When N is 11, 11 carbon atoms, e.t.c. One carbon atom is named met. 2, 8. 3, pro. 4, both. 5 is named pent. 6 is named X. 7 is named X. 8 is named Art. 9 is named Non. 10 is named Deck. 11 is named On Deck. 12 is named Dodec, etc. Now, this is the basic naming of all hydrocarbon. You name them starting from the word, the number of carbon atoms possessed by each and every hydrocarbon. Now, let's move to the homologous series. homologous series. Homologous series is a sequence of hydrocarbon, or is a sequence of a compound having the same functional group, and each member of that compound are differ from another with molecular formula of CH2 and molecular mass of 14. The word homologous series simply means the family of the hydrocarbons. The other time I said the hydrocarbons are classified into aliphatic, aromatic, and under aliphatic we have examples like alkane, alkane, and alkyne. So let's take one of the examples. Let's use it to explain the homologous series. Let's take alkane for instance. Alkane as the homologous series, the family. Under this family, all the members have the same functional group. All the members have the same functional group, and each and every member are differ from another with molecular formula of CH2 and molecular mass of 14. Another characteristic of the members of the homologous series is that they all have the same general formula. For instance, the general formula for alkane is CN H2N plus 2. Like I said the other time, the N represents the number of carbon atoms found in each and every member of hydrocarbon. For instance, if N is equal to 1, then you have C1 H2 into bracket 1 plus 2. This is equal to CH4. This is the first member of alkane family, or homologous series alkane, the first member of alkane family. And I said, if the number of carbon is 1, the name is met. The name is what? Met. So the name of this is met. Then what ends the name is the functional group the homologous series or the family belongs to is N. The functional group is N. So the name of the first member of alkane is methane. I said the other time that each member of the homologous series, they are different from another with what? CH2. Add CH2 to the first member, you have C2H4, which is the second member. Add CH2, we have C3H6, which is the third member, C4H8, C5H10, e.t.c. The common number here is 2, so this is called ethane. The carbon number here is 3. 3 is pro. The functional group is N. This is called propane. This 4, both. The functional group is A, butane. This is called pentane, and so on and so forth. Now let's look at the physical properties of alkane family. Number 1, the first member of alkane family, to the fourth member of alkane family, that is the methane, the ethane, the propane, and the butane, are all gases at room temperature. They are all gases at room temperature. The fifth member to 14th member are liquid. at room temperature. The 15th member downward as solid at room temperature. This is the number one physical property of alkane family. Number two, their boiling point, the melting point, the density of the members of the family increases as the number of carbon increases. The density, the boiling point, the melting point of each member of the family increases as the number of carbon increases. Then, let's look at the chemical properties of alkane. Alkane has two major chemical properties. Number one, combustion. Number two, substitution reaction. Now the first one, combustion. This means all alkane family or member burn in the presence of oxygen to give carbon 4 oxide and water. Note, the reaction is exothermic because the reaction liberates heat in energy in form of heat, as shown above. We have, let's use the first member, methane plus oxygen. Now, this is a reaction that shows the combustion of alkane, one member of alkane family. All the members undergo the reaction, but this is only showing the first member of alkane family. Then balance the equation. You have one carbon, you have 4 hydrogen. You put 2 here to make it 4. Then you have how many oxygen? You have 2 oxygen. Here you have 4 oxygen. Then you put 2 here, balanced. The second reaction, called substitution reaction. This reaction simply means one hydrogen atom from alkane family are replaced by either halogen family or any other family. E.g., for instance, we have CH4 plus chlorine gas. In the presence of ultraviolet radiation, one chlorine atom will replace one hydrogen atom from this methane to give CH3Cl plus HCl. In the presence of more chlorine gas, the reaction will continue. CH3Cl plus more chlorine gas. In the presence of UV, we have CH2Cl2 plus HCl. This reaction will continue in the presence of more chlorine gas until all the replaceable hydrogen atoms from methane are all replaced. In this reaction, you see the formation of chloromethane, dichloromethane, trichloromethane, and so on and so forth. The next subtopic is alkane. The next subtopic is alkane. Another homologous series, alkene. Unlike alkane, alkene has a general molecular formula of CnH2n. And the first member of alkane, the number of carbons starts from 2. So when N is 2, the first member is going to be C2H4. And I said the other time that each member of the family are different from another with the molecular formula of CH2. Add CH2 to this, you have C3H6. Add CH2 to this, you have C4H8. Add CH2 to this, you have C5H10. Add CH2 to this, you have C6H12, e.t.c. Unlike alkane, that the first member is methane, the first member of this homologous series, alkane, is 18, is C2, 2 carbon atom, 8. Then the functional group, N, 18. Propene, butene, pentene, hexene, and so on and so forth. Now, before we discuss about the physical properties and chemical properties of alkane, let me quickly explain one of the members of aliphatic alkyl group. Alkyl group has general molecular formula of CnH2n plus 1. It is an unstable hydrocarbon because the number of bonds surrounding the carbon is incomplete. With this general molecular formula, the first member, when n is equal to 1, is going to be CH3. Add CH2 to the first member, you have C2H5. The third member, C3H7. The fourth member, C4H9, and so on and so forth. Likewise, the name, METS. The functional group, IL, methyl. X, the functional group, IL, ethyl. We have propyl. We have butyl, and so on and so forth. Like I said earlier on, the reason why I quickly explain this is because most of these members, since they are incomplete, they are unstable, most of these members are used as substituent, attaching to the root of any hydrocarbon family. When we start the nomenclature, the naming of all hydrocarbon, you understand better. So let's go back to our alkane, the physical property of alkane. Physical property number 1. The first member to number 4 are gases at room temperature. The fifth member to number 14 are liquid at room temperature. The 15th member downward are solid at room temperature, just like the alkane. Number 2, the boiling point, the melting point, and the density of each member of this family increases as the number of carbon increases. Now, unlike alkane, they are slightly polar. Alkane are non-polar. So alkane only dissolve in polar solvent like benzene, But alkene, they are slightly polar. So some alkene dissolve in alcohol. The chemical properties. Number 1, combustion. Combustion. Number 2, addition reaction. Number 3, polymerization reaction. Now let's look at it one after the other. The first one, combustion. Combustion simply means burning of an alkene family in the presence of oxygen to produce carbon dioxide and water. The difference between the combustion of alkane and alkene is that alkene burn with little soot, as shown above. The first member, C2H4 plus oxygen, give CO2H2O. Just like I said the other time, this reaction is exothermic. They liberate or give heat to the surrounding. The second one is addition reaction. Under addition reaction, since alkene are unsaturated hydrocarbon, permit me to say this: all hydrocarbons are divided into two based on the number of bonds between the carbon atoms. We have saturated hydrocarbon and unsaturated hydrocarbon. What are saturated hydrocarbon? Saturated hydrocarbon are hydrocarbon that have single bond between the carbon atom. Example is alkane, the first member. Unsaturated hydrocarbon are hydrocarbon that has double bond or triple bond between the carbon atom. A good example is alkene and alkyne. So one of the differences between the saturated hydrocarbon, which is alkane, and the unsaturated hydrocarbon, which is alkene and alkyne, is that the unsaturated hydrocarbon burn with sooty flame. Burn with what? Sooty flame. So the combustion of unsaturated hydrocarbon, which is alkene and alkyne, comes with a soot, while the combustion of alkane is straightforward. The second difference between the saturated and unsaturated is that the unsaturated hydrocarbon, because of their unsaturation, they decolorize bromine water or potassium permanganate solution, while the saturated hydrocarbon, the member of the alkane family, has no effect on bromine water or decolorization of potassium permanganate solution. Let's go back to our chemical properties. Number 2, addition. Under the addition reaction, it can be in form of hydrogenation. It can be in form of halogenation. It can be in form of hydrohalogenation. e.t.c. We use the first one to explain addition reaction. Hydrogenation is the addition of one atom of hydrogen to alkene family in the presence of nickel and over 150 degrees Celsius temperature, as shown below. That is of alkane. Number 1, the state of matter of the member of alkane. The first member to fourth member are gases. at room temperature. The 5th member to 14th member are liquid at room temperature, that is from pentene to tetradecane are liquid at room temperature. The 15th member downward are solid at room temperature. Unlike the alkene family are partially non-polar. So because of that, they dissolve in alcohol, but just like an alkane, they cannot dissolve in water. That is the solubility. The first one is the state of matter of the member of the alkene family. The second one is under the solubility. They cannot dissolve in water, but they are partially non-polar, so they dissolve in alcohol. Number 3, the boiling point, melting point, and the density of the members increases as the number of carbon increases. The chemical properties. The chemical properties. Number 1, combustion. Combustion means burning of a compound in the presence of oxygen. All alkene family, all the members burn in the presence of air to liberate heat and give byproduct of carbon dioxide and water. The difference between the combustion of alkane and alkene is from the type of bonds between the carbon atom of the member of each family. Based on that type of bonds, all hydrocarbons are divided into 2. We have saturated hydrocarbon and unsaturated hydrocarbon. Saturated hydrocarbon are hydrocarbon with single bond between the carbon atoms. While unsaturated, e.g., example of saturated hydrocarbon is alkane. While unsaturated hydrocarbon are hydrocarbon with double or triple bond between the carbon atoms. Example, alkenes with double bond and alkyne with triple bond. So, all hydrocarbons born in the presence of oxygen, they all undergo combustion, the chemical properties. But the difference between the combustion of a saturated hydrocarbon, which is alkane, and unsaturated hydrocarbon, which is alkene and alkyne, is that the unsaturated hydrocarbon burn with sooty flame. Secondly, the unsaturated hydrocarbon decolorize bromine water and the solution of potassium permanganate, while the saturated hydrocarbon has no effect on bromine water and the solution of potassium permanganate. So let's look at the combustion. The first member, ethane, C2H4 plus oxygen to give carbon dioxide, water, and heat, an exothermic reaction. The second chemical properties of alkane is addition reaction. Addition reaction. What is addition reaction? This is a reaction that involves the addition of one atom of hydrogen or one atom of halogen to alkene family. One atom or 2 atoms of hydrogen or halogen or hydrohalogen to alkene family. So under addition, if it is hydrogen that we are adding, it is called hydrogenation. If it is halogen, either chlorine, fluorine, bromine, or iodine, is halogenation. And we can also have hydrohalogenation, the addition of one atom of hydrogen and one atom of halogen. Let me use the first one as an example. C2H4 plus hydrogen gas. In the presence of nickel as catalyst and 200 degrees Celsius heat, the reaction will take place and we'll see a formation of C2H6, converting alkane to alkane, converting unsaturated hydrocarbon to saturated hydrocarbon. Number 3 chemical reaction. We have polymerization. This is the addition of simple alkene family to form a giant alkene. The addition of simple alkene family called monomers to form a giant alkene family called polymer. For instance, ethene, many monomers of ethene combine to form polyethylene. Now, before we discuss alkyne, let's look at the naming of branched hydrocarbon, the naming of branched alkane, naming of branched alkane. It is called nomenclature. Nomenclature of branched hydrocarbon. Nomenclature of branched hydrocarbon. Let's take for instance CH3, CH2, CH3, CH2, CH2, CH3, CH3. Let's name this branched alkene. Now, to name this, we have to follow the following rules in naming branched hydrocarbon. Either alkane, branched alkane, branched alkyne, or branched alkane. And we follow this. We have prefix, we have roots, and we have suffix. The roots stand for the carbon chain found in that branched hydrocarbon. Now, let's use the procedure to name this branched hydrocarbon. Number 1, select the longest carbon chain. 1, 2, 3, 4, 5 is long enough. 1, 2, 3, not long enough. 1, 2, 3, 4, 5 is long enough. So we can decide to choose this straight chain as our longest carbon chain, and we use this branched chain as our longest carbon chain. You can also select the longest carbon chain from either end. 1, 2, 3, 4, 5. Longest carbon chain. 1, 2, 3, not long enough. 1, 2, 3, 4, 5. Now, the one you are selecting will depend on the position of the attaching alkyl group to the longest carbon chain. the attaching alkyl group or any attaching substituent to the word longest carbon chain. Now, number 2, we assign numbers to the carbon chain. You can assign from any of the end. Let's assign from here carbon number 1, carbon number 2, 3, 4, 5. And we can also decide to number from this end to this end. Carbon number 1, carbon number 2, carbon number 3, carbon number 4, and carbon number 5. Now, the first thing you must identify is the longest carbon chain. This is our longest carbon chain, 5 carbon. So our root is pent. I said earlier on that if an organic compound is having 5 carbon atom, the name is pent. If it is 4, it is both, but if it is 3, it is prop. Now, after you have identified your root, the next thing is to identify your functional group. Single bond, the functional group is A. We are done with the root and the suffix, which is the functional group. The suffix identifies the functional group, the root identifies the longest carbon chain. Now the next is to identify the prefix, which is the word, the alkyl group or any other group attaching to the longest carbon chain. Now, we are identifying this as the longest carbon chain, so this and this is going to be our prefix. We call it substituent. We call it what? Substituent. Now, let's look at the next procedure, the next rule. The longest carbon chain becomes the root, the substituent becomes the prefix, while the functional group becomes the word suffix. The next one. Hyphen are used to separate prefix from the root and commas between location of the substituent. Now, when we want to name from this end to this end, we'll discover that the first substituent is attaching to carbon number 2, while the second substituent is attaching to carbon number 4. 2 and 4. Naming from this end to this end, the first is attaching to 1, 2, carbon number 2. The second is attaching to 4, carbon number 4. So we can name from either end. What is the name of the substituent? This compound is familiar. From alkyl group, the name is methyl, the first member of alkyl group, CH3. You remember? Methyl. So how many substituents do we have? We have 1, 2. 2 the same substituent. And also, if you have more than one substituent and they are the same, you use the word di for 2, tri for 3, tetra for 4. Look at rule number 5. The words di, tri, tetra are used if there are 2 or more the same substituents. So, how many substituents do we have here? 2. We have the first one is attached to carbon number 2. The second one, carbon number 4. 2, 4. How many? 2, the same. Di, what is their name? Methyl. Methyl pentane. That is name for this compound. If you name it from this end to this end, you get the same thing. Because the first one from this end to this end is attached to carbon number 2, the second to 4. So we have 2,4-dimethyl pentane. Because of our time, we are going to stop here and we'll continue from our next class. Thank you. I remain Bamidele Bakari.